Now, second problem is, if z1 and z2 are two complex numbers such that mod of z1 plus z2 is equal to mod of z1 minus z2, then prove that difference of their amplitude is pi by 2. So here we have been asked to prove that the difference of the amplitude. Now amplitude is nothing but argument, which is nothing but theta. So difference between the amplitude of first complex number and the second complex number is pi by 2, which is 90 degree. So to prove this, we have been given a condition, that is mod of z1 plus z2 is equal to mod of z1 minus z2. So using this given result, we will prove something, and that result we will use to prove the question which is being asked, right? So to prove this we will use this result, mod of z1 plus z2 equal to mod of z1 minus z2. But before that, it is also given that z1 and z2 are two complex numbers. So let's assume the value of it. So I'll say let z1 is equal to x1 plus iy1 and z2 is equal to x2 plus iy2. Now this is the given condition. So I will write it down. Now mod of z1 plus z2 is equal to mod of z1 minus z2. So what we will do is, we will substitute the values of mod of z1 plus z2 and mod of z1 minus z2 over here. So what is mod of z1 plus z2? So for that we will first find out z1 plus z2 and then we will find out the mod. So we will get x1 plus x2 and y1 plus y2. Now what is this? This is nothing but addition of two complex numbers z1 and z2. So when we will add z1 and z2, that time we will get x1 plus x2, that is addition of real parts, and iy1 plus iy2, that is addition of imaginary part. Now this is the value of mod of z1 plus z2. Similarly, if we want z1 minus z2, we will get x1 minus x2 plus y1 minus y2. Now we will find mod of this part, that is z1 plus z2, and mod of z1 minus z2, and value of which we will substitute in the given condition. So therefore this given condition becomes z1 plus z2 mod, that is square root of x1 plus x2 the whole square plus y1 plus y2 the whole square. Similarly, on right hand side, z1 minus z2 mod will become root of x1 minus x2 the whole square plus y1 minus y2 the whole square. Now we can take square on both sides. Why? So that square root will be removed. So taking square on both sides, so we will get on left hand side x1 plus x2 the whole square plus y1 plus y2 the bracket square. Similarly, on RHS we will get x1 minus x2 the whole square plus y1 minus y2 the whole square. Now we will expand these brackets by using the formula a plus b the whole square and a minus b the whole square. So this will become, therefore, x1 square plus 2 times x1 x2 plus x2 square. This term will become y1 square plus 2 times y1 y2 plus y2 square. Similarly, on RHS we will get x1 square minus 2x1 x2 plus x2 square plus we will get here y1 square minus 2y1 y2 plus y2 square. Now what we'll do is, we will cancel similar terms on both sides, like x1 square on LHS and x1 square on RHS. It will get cancelled out. Then x2 square, then y1 square, then y2 square. And we will take all the remaining terms from RHS to LHS. So here we have minus 2 x1 x2. So when it comes on LHS, it means it is crossing boundary. तो अभी वो पाकिस्तान में अभी आ रहा है, वो इंडिया में आ रहा है. तो जब वो बाउंड्री क्रॉस कर रहा है तो नेगेटिव है, तो उसको पॉजिटिव बनाएंगे. तो 2x1 x2 यहाँ पे ही है. ये जो माइनस है जब वो लेफ्ट में आ रहा है वो भी प्लस हो जाएगा. So 2x1 x2 plus 2x1 x2 will become 4x1 x2. Similarly, minus 2y1 y2, when it will come on LHS, it will become plus 4y1 y2 equal to, now nothing left on RHS, so we'll get 0. Now from both these terms we can take 4 as common, and x1 x2 plus y1 y2 will remain in bracket equal to 0. So we will get 4 x1 x2 plus y1 y2 equal to 0. Therefore x1 x2 plus y1 y2 is equal to 0. Now this is result number 1. So from the given condition we got this result. Now this result is very useful for us to prove the given question. Now here we have been asked to prove that the difference between amplitudes of two complex number. So therefore amplitude of first complex number, that is Z1, minus amplitude of second complex number, that is Z2. We need to prove that this difference is equal to pi by 2. So now what I will do, we will first find what is amplitude of Z1. Now हमने Z1 को consider किया था x1 plus iy1 और amplitude is nothing but theta. तो इसका amplitude आएगा tan inverse of y1 upon x1. Similarly जो second complex number हमने लिया था Z2 वो था x2 plus iy2, तो उसका amplitude आएगा tan inverse of y2 upon x2. अभी अगर आप यहाँ पे देखेंगे तो यहाँ पे हमें एक फॉर्मूला मिल गया tan इनवर्स ऑफ a माइनस tan इनवर्स ऑफ b. तो उस फॉर्मूला को हम अप्लाई करके इस वैल्यू को देखेंगे क्या वो पाई बाई 2 आता है क्या, राइट. सो tan इनवर्स a माइनस tan इनवर्स b का फॉर्मूला क्या है, इट इज tan इनवर्स a माइनस बी अपॉन 1 प्लस ए बी. ये बेसिक 11th स्टैंडर्ड में हमने जब इनवर्स ट्रिग्नोमेट्रिक फंक्शंस किया था 12th स्टैंडर्ड साइंस में या 11th साइंस में, तभी आपने ये फॉर्मूला देखा होगा. यस, यही फॉर्मूला मैं यहाँ पे अप्लाई करता हूँ तो मुझे मिलेगा tan इनवर्स. नाउ इफ आई विल कंपेयर दिस टर्म्स विद द फॉर्मूला देन आई कैन से दैट a इज y1 अपॉन x1 and b is y2 upon x2. So I will get a minus b, that is y1 upon x1 minus y2 upon x2 whole divided by 1 plus a into b. A is y1 upon x1 and y2 upon x2. Now next step, in the numerator I will take LCM and I will get x2 y1 minus x1 y2 upon x1 into x2. Similarly, here in the denominator I will again take LCM so that I will get x1 x2 plus y1 y2 upon x1 x2. Now from this numerator and from this denominator we can cancel x1 x2 and x1 x2 because they are similar terms. Now we get tan inverse of x2 y1 minus x1 y2 in the numerator and x1 x2 plus y1 y2 in the denominator. और यहाँ पे जो हमें डिनोमिनेटर में टर्म मिला है, यू कैन सी दैट इन द रिजल्ट 1 हमने उसको प्रूव किया है दैट इट इज़ इक्वल टू 0. मतलब अगर ये वैल्यू फ्रॉम 1 अगर मैं बोलूँ तो डिनोमिनेटर 0 हो जाता है. तो I can substitute that equation 1 in this result and I will get denominator as 0. और जब भी डिनोमिनेटर 0 होता है तो आंसर आता है इन्फिनिटी. सो वी गेट tan inverse of infinity and you all know that tan inverse of infinity is pi by 2 because tan of pi by 2 is infinity. Hence, when tan goes on RHS, it becomes tan inverse of infinity. So, it means tan inverse of infinity is pi by 2. Hence, our answer is pi by 2. So, ultimately, difference between amplitude of two complex numbers is equal to pi by 2. We have proved the result.